Hello everybody, today I'm going to explain the solution to the second problem from the 2025 USACO January contest in the bronze division. The second problem being it's Mooin time 2. In this problem, we are given an array of length n, and if you remember the problem from the last contest, from the December contest, just like there, we need to count how many of these Mooin subsequences we have here. And we need to count how many distinct ones we have. And a Mooin subsequence is a subsequence such that the first number is different from the second number, and the second number is the same as the third one. For example, 144 is a Mooin, or also 244, and so on. If you think of how Mooin is spelled, you want to basically have the last two letters equal and the first one different. And now in this problem, we need to be careful to not count the same Mooin more than once, because we can't count, let's say, 144 three times, because it does show up three times if we look at all subsequences, this one with these two, or with this one and this one, or with these two. We must only count it once. And in order to do that, we need to be careful at the way to count these things without actually overcounting. And given that n is very large, up to 10 to the 6th, we can't really brute force our way through this solution, because doing an n cube would be way too slow, just counting every single triple, or even n squared by having some sort of an optimization would still not really do it, because it would be way too slow. Now, we need to think at a way to count without much trouble. So if we look at, let's say, this sample, even though it's not a very difficult sample, it is representative enough for what I'm going to show you throughout the solution. And if we were to not have the restriction about distinct, let's say, moves, one idea which is very natural for these sorts of problems is to fix the character from the middle, and basically count how many characters to the right are equal to it. So count these two, and also count how many distinct numbers we had on the left, distinct numbers other than the current one. And if we think about it, this can be done without much difficulty by storing a frequency array at the beginning with the frequency of every character, every number. So for example, if we have the frequency of 1, it shows up once, the frequency of 2 shows up once, frequency of 3 shows up once, and the frequency of 4 is 3. And as we go through the characters, we would always decrement the frequency of the current number, while also store somewhere the number of distinct values we had so far. We can do this with either another frequency array or by using like a hash map. So there are many ways of getting this done. And if we develop from this solution, then at every position we would be able to keep track of the number of distinct values. So we would have distinct here, and we would multiply it by the frequency of the remaining numbers. But for distinct, we might have to subtract 1 in case we already have the number in question. Now, like I said earlier, this is not a correct solution. It would count a lot of moves multiple times. However, I'm going to claim that this solution is going to be essential towards helping us find the actual answer. And why I'm saying this is because one weakness the previous solution had was the fact that if we had many of, let's say, these fours, we would count a lot of moves a lot of times. Like I mentioned with 1 and counting 3 moves, even though it's only 1. And a way to avoid doing that is for each pair of two numbers that are equal, to focus only on the very last two positions when it shows up. And the reason why we want to do that is because if we go too early, we have overcounting, like I mentioned earlier. If we go too late, we miss out entirely on this possibility of generating moves. And what are the last two numbers equal here? And we do this for each number, obviously. The last two positions would be these two fours. They don't have to be consecutive. For example, if we were to have had a configuration like this, so let's say something like 454, we would have still considered these two fours. So now what we will do is, if we have a number that shows up at least two times, we will only care about the second to last position it shows up, so this one here. And for this position, we will count how many distinct values to the left of it we had. Obviously, we want to exclude the current number if it shows up there before as well. And by doing it, I claim that now it is enough to count the actual answer, because we maximize the number of moves we obtain for a given number, while we also limit and remove entirely the possibility of having overcounting. Because now we don't wait anymore, but also we don't rush with having a certain move. And as you will see in the implementation, this is actually a matter of just finding the frequency array for each number from 1 to n, and then do a traversal in which we count how many distinct values we have at some point in the array. You need to take note that frequency array problems have showed up a lot as of late, and it's a very important concept, especially nowadays. And now I'm going to show you the code. Basically, I read the array and I kept track of the frequency of the values. Take note that I used two frequency arrays because I want to use the frequency from right to left, as well as the frequency from left to right. Very important to have both of them in order to count the number of distinct values, as well as to check whether an integer is the second to last one we had. And if we go from 1 to n, we remove the number from the second frequency array. We check if it's the second to last one. Here I count the number of distinct values, but I also have here an if statement that basically checks whether we had the current number to the left. So if I were to write this without this short form, I would have had an if where I had to check whether this is greater than 0 or not. So again, I added to the answer the number of distinct values and dealt with the special case. And if we have a value showing up for the very first time, then we add 1 to the number of distinct integers. And at the end, we need to print the answer, but we need to be very careful because the answer can become very large, and thus we need to use long in order to avoid overflows, or long from the Java language. Python programmers don't have this issue, so it's not a problem in that perspective. And this was the solution for this problem, a problem where we used frequency arrays and we dealt with some very important observations to avoid overcounting the answer. And the solution presented is a solution which runs in linear time. If you enjoyed watching this video, please like the video, subscribe to the channel, and share it with your friends or with any other people you know who are taking USACO contest. In addition, if you have any sort of feedback or you want me to do videos on certain problems, please let me know in the comments so that I can work on them in my free time. In addition, if you or someone you know is interested in working more closely with me as part of my tutoring program, please check out the links in the description to see my website and ways to interact with me and to continue your USACO journey in a successful manner. Until the next time, good luck with the USACO contests. Please check out the other videos I made in the channel, and see you next time. Cheers!